The graph of the quadratic function 3 ways. The graph of a quadratic function in a single variable is a parabola. In the last unit, the focus was on the graph of a quadratic in standard form. Its equation is given by f of x equals ax squared plus bx plus c. Standard form is one way to represent a quadratic function. After a short review of standard form, we will turn our attention to two alternate forms: x-intercept form, which is a times x minus r times x minus s, and vertex form, a times x minus h squared plus k. Together, these three forms provide a comprehensive understanding of the quadratic function. Some features of the parabola. Here we have our three forms: standard form, x-intercept form, and vertex form. Our x-intercepts are at r, 0 and s, 0. Our axis of symmetry here is at x equals negative b over 2a. The vertex is at h, k. If a is greater than 0, that means the parabola opens upwards. If it's less than 0, then it opens downwards. All of these coefficients are real numbers, and the domain of the quadratic function is the set of real numbers. Recall, the discriminant is the quantity that will indicate whether the quadratic function has two complex, one real, or two real solutions. The three possible scenarios. The discriminant is negative, less than 0. The square root of a negative is undefined. Therefore, there are two complex solutions. If the discriminant is equal to 0, the square root of 0 is 0. There will be one real solution. If the discriminant is positive, the square root of a positive number is a positive number. Therefore, there's two real solutions. Here are graphs of the three possible scenarios. If the discriminant is negative, then there is no solutions. So as you can see, this parabola never crosses the x-axis. This is two complex zeros, so there's going to be imaginary numbers here. In this scenario, the discriminant equals 0, therefore there's one real solution, and you see how that's represented by one intercept there. And the discriminant being positive will have two real solutions there and there. We see an example. Notice that the terms zeros and solutions are interchangeable. The solutions of quadratic equations are the zeros / roots of their quadratic functions and the x-intercepts of their graphs.